Hi, Nancy Sliger, wanting to go over some of the questions from the practice test with you on scientific method. Your actual test will not be as difficult as what some of these questions are. I gave you some harder ones, so you'd be ready for the test when you take it on Tuesday. Um, Also, I'm recording this at home, so my phone may go off, or you may hear a dog barking, and I'll pause it and come back to the video. So, number one, they're wanting you to identify what the independent variables are, the dependent variables, and the constants. The constants are something that's same for all trials. And so here you can see that the amount of water and the temperature are the same. What they're varying is the temperature to see if the temperature of the water has any effect on the amount of sugar that it will dissolve. So the independent variable is that they're changing the water temperature. What depends on the water temperature is how much sugar will dissolve. This question here, they're asking you to determine independent, dependent, variable, and constants. So this is the effect of temperature on enzyme action. So enzymes are chemicals in your body, and they can run analysis in labs. They can change the effect of temperature and see if the enzyme is more active by breaking down things as the temperature increases. So they have a control group and four test groups. They all pretty much have the same water, so that's a constant. They get the same amount of starch, that's the same. They all pretty much have the same amount of enzyme amylase, so that's a constant. What they're changing is the temperature. That's your independent variable, is what I can change. And the result of changing the temperature is the activity of the amylase. So that's the dependent variable. The purpose of a controlled experiment is to allow scientists to isolate and test one variable. If you have multiple variables and you get a result, you may not be sure what was the actual cause of the result. So basically, controlled experiments, they're just testing one variable to see if it has an effect. This experiment here, they're obviously growing plants. You can see that they all have the same amount of size light bulb. They all get the same amount of light, 8 hours per day. They're all being tested with the same kind of plant, bean plant. All the plants are in the same amount of soil. What is different is the pH level of the soil, which is how acidic or basic it is. So hours of light exposure are the same, so that's a constant. They're using the same plant, so plant species is the same. They all got the same amount of soil. That's a constant, but they're changing. What they can change or what I can change is the soil pH. That's the independent variable. The result of the pH of the soil is how much the plant will grow. And then all the plants had the same size light bulb on them. Here you have obviously people running. You have group A, B, C, and D of runners. And if we look at the average distance they run, well, they're all running different amounts. They all had pizza. What's different here is what they're drinking. They all got the same amount of sleep, and they're all wearing the same kind of shoes. So which one of these is the control group? This is what you want to compare your results to. So you have people drinking Kool-Aid, Gatorade, water, Powerade. Your best control group here is going to be the people drinking water, because it's not going to have sugar or salts in it that might affect how the body responds and maybe give them more energy to run. So here it's group C is your control group. Um, Identify all the constants needed for this experiment. Plants, they're both getting 200 milliliters of water, but only this plant here is getting fertilizer. So they both get 200 milliliters of water. Only one's getting fertilizer. They're probably going to get the same amount of light. Um, they should start with the same height of plants, and they should water the plants at the same time. So those are things they should keep constant. Suppose a scientist proposes a hypothesis about a newly discovered virus affecting humans. Other virus researchers would likely reject it right away. Not necessarily, not if it's a good hypothesis. Change the hypothesis to fit their own findings. A good scientist wouldn't do that. Design new experiments to test the proposed hypothesis. They would probably do that and assume the hypothesis is true for all viruses. Probably not, because they wouldn't just necessarily believe what everybody told them. But they could go in and design some experiments to see if this hypothesis is going to hold true. Science differs from other disciplines such as history and the arts because science relies on facts. The first step of the scientific method, these are your choices. So they want to know what comes first, and that would be a question. You have a natural curiosity about something. This one here is to put the order of the steps in the correctly based upon the scientific method. So on this one here, she's worried about her bamboo plants, and she's going to give them different amounts of water. So she would probably have to first observe that there was a problem with the plants on the kitchen window, so they were dying. Then she would probably ask a question as to why they're not growing well. And of the next choices, she would probably hypothesize how much water the plants needed. Then she could design her experiment to see what would be the correct amount of water. So she made her results, and only the 15 milliliter one showed the most growth. So then she drew a conclusion. And that's how you set those up. This one here's here's the parts of an experiment. You identify what those parts are. This was about the coach wondering which paint would be better on a football field. So if you look at all these, formulate a hypothesis. That would be like an if-then question. So state a problem or ask a question. And then going to the hardware store and reading labels in order to compare paints. That would be gathering research. He thinks the new kind of paint will last longer than the usual paint. That might be his hypothesis. He paints one field with the usual paint and a field right next to it with a new type of paint. That would be conduct an experiment. He checks the paint every week during the football season, records his observations. Notes the field with the usual paint comes off more, so that's record and analyze data. Will the new type of paint last longer than the usual paint? Let's see. That's state a problem. The type of paint used would be the independent variable because that's what he's changing. The football field would be a constant. The durability of the paint would be the dependent variable. Deciding that the paint lasts longer would be his conclusion. All right, I'm going to stop the video here at number 11 and I'll pick up at the next video.